Hi, today we're going to be talking about one-sided limits. Up until now, we've been talking about two-sided limits. We look at the limit as we approach a number, and we look at that number from the right and left sides. Well, one-sided limits are just that. We're only going to look from the right side or from the left side. So here's how you know the difference. A right-handed limit is going to have a little plus sign next to whatever this a value is. So let's say it's the limit as x approaches the number 5. Well, if that 5 has a little plus sign to it, that means we're going to look at the graph as we approach the number 5 from the right side, not the left side, but just the right side. And a left-handed limit would look like this. See that little minus sign on the right side of the a value? So if there's a negative in front of the a, then it's just a negative number, like -5. But if there's a negative to the right of it, that means we're looking at this graph, whatever f of x may be, and we're going to look at how it approaches, let's say 5 from the left. So for an example here, we're going to start out with a piecewise function just to show you how these can create different answers here. Okay, so I'll start with this first. Here's this piecewise function. F of x equals x plus 6. That's a line going through the y-axis at 6. And we're only going to see that line for x values less than 2. So that's this right here, a line going through the value of 6 here on the y-axis. And it's for all values less than 2. So here's 2, open dot, everything less. Now, the line f of x equals 5, well, that's just a horizontal line that goes through the y-axis at 5 like this. But we only want to see it at 2, so basically just erase everything that I just showed you, and it's just a dot. And then the last one is a parabola, because I see the x squared here. 1/2 x squared for all x values greater than 2. So, well, at 2, it's right here, so put an open dot, and then it's looking like that. So right now, I want to take a look at the limit as x approaches 2 from the right side. So here's the number 2. I'm only looking at how we approach the number 2 from the right side. So I'm not looking at any of this stuff over here. So as I approach 2 from the right side, I'm basically just looking at that parabola, the 1/2 x squared. So the limit as x approaches 2 from the right, that's what that 2 means. Well, as we approach number 2 from the right, these values are getting closer and closer and closer to the number 2. So that's the limit. Now, if I approach the number 2 from the left side, that's what the little negative means. Here again is the number 2. If I'm approaching from the left side, not equaling 2, but approaching it from the left side, I'm looking at this line then, because these are the numbers leading up to the x value of 2. So these values, as we get close to the number 2, not touching it, we are getting closer and closer to the number 8. And that's why the limit is that. So another example, if I just have the basic square root function, square root of x, it looks kind of like this. If I want to approach the x value of 0 from the right, here's 0. If I approach it from the right, so again, just looking from the right side of the graph over to it, it's getting closer and closer to the number of 0. So that's why that limit is 0. And if I approach x is approaching 0 from the left side, well, it doesn't exist on the left side, okay? A square root graph begins here because only positive values of x can go in here or 0. So it doesn't exist anywhere to the left. Therefore, we say DNE, does not exist. So you can see if I'm approaching from the right or left, it can sometimes create different answers, and sometimes it'll make answers the same. I'll make sure to do an example of one where it comes out the same in a little bit. Okay, so here we've got another graph. F of x is this function here, x squared over 3 times x plus 2. And if you're looking at this graph, if I'm approaching -2 from the right, I want to make sure I put in a negative example in here because that is -2. how we approach it is to the right of the number. So you can see in a second we're going to do x approaching -2 from the left side, just so you can see how that looks with a negative number. So if I'm approaching -2 from the right side, I'm basically not looking at this image down here at all. And this would be like an asymptotic point right here. This vertical line would be like an asymptote that I'm drawing. So as I approach -2 from the right, you can see as I approach -2, this graph goes up and up and up. So we would say the limit is equal to infinity. As I approach -2 from the left, so coming from this way, you can see the graph is starting to go down forever here, so that's -infinity. Now, interestingly enough, if I were to just give you this question like the other day, and I just said, find the limit as x approaches -2, that would mean I'm looking how we approach -2 from the right and left sides. Since I'm approaching -2 from the right and left, and it's going in two different directions, this side's going up, this side's going down, I would say that the limit as x approaches -2 does not exist. So specifically, as you approach it from the right or from the left, we can get answers to those though. This would be an example down below of where it doesn't matter which angle you approach it from, all the answers are the same. If I just give you this graph over here, and I ask you to approach this a value from the right, well, if I'm approaching the a value from the right, where is it going? Up forever, so infinity. If I approach this graph to its a value on the left, here's a, approach from the left, and it's also going up forever, infinity. And if I had just given you this the other day, the limit of this graph as x approaches a, again, if I don't see that plus or minus on either side of the a value, I assume I'm looking from the right and left. And since when I come from the right and left, it's going to the same place, they're both going up to -infinity, that is the answer. When you're looking at it from both directions, the way you approach a from the left and right, the answer has to be the same in order to write down an answer. So if I'm approaching a from the left and right, since they're both sides are going up to infinity, then I can write an answer. If those values, like the previous example, are approaching a number and it's going in different directions, one's up, one's down, that's where it does not exist. And maybe I'll throw in one more for good measure here. Let's do this middle one here. I'm looking at this example here. So there's just a function I have drawn. Here's an a value. If I approach the a value from the right, so I'm approaching the a value from the right, the graph is going down forever, I would say -infinity is that limit. If I approach the a value from the left, coming this way now, I'm following this track, it's going up forever, infinity. And if I just tell you or ask you, find the limit as x approaches a, that means you have to be looking from both sides. So if both sides zero in this a value and they're going to the same place, I can write that down. But they're not zeroing in and going to the same place. When I look from the left and from the right, they're going in two different places. The left side's going up, the right side's going down. Therefore, a limit does not exist as you approach the a value from both directions. So, if you would like some more examples on this, your textbook, page 849, 1 through 15 odd, can help you out there. Actually, suppose I can even just run this through and let you see the answer key. There's the last ones. And then page 842, 1 and 3, I also have other questions in there. So we've got one more lesson after this, and then again, I'm just going to give you a nice, simple quiz. Should be pretty simple if you've been paying attention to these videos. I'll post that quiz next week, and then you'll have an extra credit assignment if you choose to do it the following week, which would be the June 8th, 9th, and 10th dates. So have a good one.